Hey everyone, today we're going to start learning how to solve radical equations. First thing I want to just go over though is how to undo different operations. So undo addition, we subtract. Undo multiplication, we divide. Undo square roots, we're going to square things. So that's what we're going to be working on today, how to undo square roots. Some of the other things that we've done in the past, like how to undo addition, subtraction, multiplication, division, we're going to use that as well today when we have some equations later on. So I created this so that the odd ones are the same type of problem as the even ones. So I'm going to show you how to do the odd problems, and then I'll have you try the even ones on your own. So for problem number 1, we have the square root of x equals 6. Right now, x is inside our radical. So we want to get the x out of the radical. So to undo our square root, we are going to square both sides. So I'm going to square this side here, and I'm going to square the 6 as well. What you do to one side, you have to do to the other to keep it balanced. So again, the square root symbol and the square gets the x outside of that radical. So now we have x equals 6 squared, or 6 times 6, which is 36. And you can always check it. Is the square root of 36 equal to 6? And the answer is yes. So our answer is x equals 36. So I'm going to ask you to pause the video and try number 2 on your own. So did you square both sides first? And then the radical and the square undo each other? So you got y equals 4 times 4, which is 16. If you did, great job. That is the correct answer because the square root of 16 is 4. So 3, we'll do this one together. So again, we have the square root and x plus 2, that's all under the radical, and it equals 3. So to get that x plus 2 expression out of the radical, we're going to square both sides of the equation again. So square, square. So when we square the left side, we get x plus 2. You don't square any of those values, you just take out what's under the radical. And then 3 squared, 3 times 3 is 9. So now we'll subtract 2, and we get x is 7. And does that make sense? Let's do the check. Square root of 7 plus 2, let me make that plus better, is the square root of 9, which is 3. So that does work out. So we know for 3 the answer is x is 7. So go ahead, pause, and try number 4. All right, so for 4, did you square both sides? And that leaves you with y minus 1 equals 2 times 2, or 2 squared, which is 4. And then because we're subtracting 1 here, to undo that, we add 1 to both sides. And we get y is 5. All right, nice job if you have that. So for 5, very similar to numbers 3 and 4, we have the square root of 2x minus 6, and that's equal to 8. So again, we're going to undo that square root here by squaring both sides. So out comes that 2x minus 6. And then we do, what's 8 times 8? 64. So you have to make sure you undo your addition subtraction first. So I'm going to add 6 to both sides, leaving us with 2x equals 70. Remember what we do to one side of an equation, we always do to the other. Now to undo that multiply by 2, we're going to divide both sides by 2. So x equals, and feel free to grab a calculator at any time for any of the math assignments, 70 divided by 2 is 35. So if I were to plug that back in, I'd get the square root of, for my check, 2 times 35, which is 70, minus 6, which would be the square root of 64, which is 8. So that does check out to be what our solution was originally. So again, for 6, go ahead, undo that square by squaring both sides and see how you do on your own. So I have the first step here. Hopefully you square both sides, leaving you with 3y minus 2 equals 16. And then you add 2 to both sides to undo that minus 2. So 3y equals 18. And then to undo that, multiply by 3, we divide both sides by 3, which ends up giving us y is 6. So the last problems have a radical equal to a radical, and I like these a lot. What you're going to do when you have a radical on both sides is you're actually just going to square both sides. And what happens is what is inside that radical just comes out, and this leaves us with an equation, and we have variables on both sides. So you do want to remember there's many different options you can do to solve this. I'm going to go ahead and bring my x terms to the left side. So this is a positive 5x, so I'm going to subtract 5x from both sides. What you do to one side, you do to the other side as well. And please make sure you line up your values so that they're matching terms, and don't forget to put that x in there when you're subtracting. It's one little step, but it makes it a lot more successful when you write that in. Now I want to bring this minus 4, undo that. Bring it to the other side by adding 4. That really is a 4. So I get negative 3x equals 12. Last thing I need to do, undo that multiplying by a negative 3, so I divide by a negative 3. So I have x equals a positive 12 divided by a negative 3 is negative 4. So if I were to check that, I would have negative inside my radical, but that's okay because both of them will have that negative. So 2 times negative 4 is negative 8, and negative 8 minus 4 is negative 12. And here I get a negative 20 plus 8. So negative 20 plus 8 is also square root of a negative 12. We have not learned how to take square roots of negative numbers, but that's where our imaginary friends come into play. So I squared both sides of this equation here, and what happens is my 4y plus 2 comes out of the radical on the left, and my y plus 17 comes out of the radical on the right. So now it's up to you. You can move all the variables to the right or the left, and the constants should go to the other side because you never want to have a side that's empty with a 0. I'm going to bring my variables to the left-hand side. So that means I'm going to undo that positive y by subtracting it from both sides. So I get 3y plus 2 equals 17. And then I'll bring that constant over to the right, undo addition by subtracting, and I get 3y equals 15. Undo that times 3, divide by 3, so y is 5. Hopefully you understand how to undo radicals in our square roots, and you can try the assignment now. Good luck!